Okay, in problem number 14, we're doing linearization, and we have this function, cube root of 3x minus 4. We're told to use the linearization of it around a equals 4 to approximate another value. So first, let's get our linearization function written, and then we'll go from there. So our linearization function is always going to be f of a plus f prime of a times x minus a. So our f of x is this function. Our a is 4. Remember that in your linearization function, this x is supposed to stay in x because you have to end up with a line. So there has to be an x left in. A is the thing that you're plugging in, which is 4 in this case. So let's plug in our values and see what we get. First thing we should do, though, actually is take the derivative because we're going to need that. So this is 3x minus 4 to the 1/3 power. If I do the derivative of that, I would bring down the 1/3 times 3x minus 4. I would change the power now from 1/3 down to negative 2/3. And because of the chain rule, I have to multiply by the derivative of the inside, which is 3. And you can see that this 3 and this 1/3 would cancel out. So my derivative function is just 3x minus 4 to the negative 2/3. Okay, so now we can plug in all of our values. So f of a is plug in 4 to our original function. Well, this would give you 12 minus 4, which is 8. Cube root of 8 is 2. So we put a 2 here. Plus, what's our derivative of a? So we plug in 4 to our derivative. If we plug in 4 here, let me write this as a fraction so this will be more clear. This looks like 1 over 3x minus 4 to the 2/3. Well, if we plug in 4, this value is still 8. Now, instead of doing 1/3, we're doing 2/3, and it's on the denominator. So the cube root of 8 is 2, and then 2 squared is 4. That's on the denominator, so this becomes 1/4. And then this term is just x minus a, and a is 4. Okay, so we're almost ready to do this. Let's distribute this 1/4 and simplify this as much as we can. So this would be 2 plus 1/4 x. 1/4 times 4 would be 1, so we get minus 1. And therefore, our line would be 1/4 x. 2 minus 1 is plus 1. So this is our linearization function. L of x is equal to 1/4, 1/4 x plus 1. So now we're ready to use that to approximate a value. So we want to approximate cube root of 8.012. So what you need to figure out is, what am I plugging in for x? Well, I'm plugging in for x whatever x in my function would have resulted with 8.012 under the radical. Well, I know that if I plug in 4 for x, I get 8. So it's got to be pretty close to that. And all you need to do is figure out, you're multiplying something by 3, and you have to end up with a 0.012. So the x that we're actually going to plug in is going to be 4.004. So again, the way I got that is because I'm trying to figure out what x could I plug in here so that this value under the radical becomes 8.012. So you're really just setting up the equation 3x minus 4 equals 8.012 and solving for x. The really common mistake on these linearization problems is that a lot of students will see the cube root of 8.012 and just say, oh, that's my x. Well, that's not your x. That's what you're trying to approximate. So your x is whatever you need so that this is in the function, which is not the case if this was x itself. So what we do is we plug in 4.004 for x, and the linearization will approximate the answer for us. So we just plug that in. So what's L of 4.004? Well, we just plug that in here. We would get 1/4 of 4.004 plus 1. 4.004 divided by 4 would just be 1.001 plus 1 gives us 2.001. So by using the linearization and figuring out the x that we need to approximate this value, we approximate it as 2.001, which should make sense. It should be just barely bigger than 2, because if it was 2, we would have just got 8. But we're looking for something slightly bigger than 8, and we got something slightly bigger than 2.
The Teaching Center, UF's Learning Resource Center.